One of my favorites is think win-win or no deal. This is something I guess my children and I talk about a lot. They're in business. We try and find when we deal with others, try and be a way where everybody can win. But I want to spin this also a little bit differently for those who are engineers, particularly dimensional engineers, and that is when we want to think win-win, we want to be data-driven, but we don't want to be driven by data. Just remember, without data, all you have are opinions, and most of them stink. Too often, when people don't have data, they want to talk about it. Who's been to a meeting where people talked and talked and talked, but nobody had any data? This is a form of waste. You get into lean engineering and look at the organization and how we behave. Talking without data is waste. So let's, instead of talk about it, let's go get the data. And there'll be two cases. The data exists, in which case we have to find it, or the data doesn't exist, so therefore we need to develop it. And that's pretty simple, right? And then DCS can help on that. That's one great thing about working for DCS. We have so many tools and methods that can help you with this. To create and analyze new data, we can use the 3DCS variation analyst or DVM or PVM tools that will help us to create models, to create data, check hypotheses, etc. QDM, the Quality Data Management System, is a great method for pulling the data that has been generated at the plant through actual build data. Both tools are great. Highly recommend using them. It's great that they kind of have this synergy. But when you get the data, let's make sure that we are using it wisely. And we live in a data-rich world because we can either get a lot of plant data through QDM or generate tons of data through the variation analysis tool. But got to be careful on how we do it. Avoid mining data without a goal. How do you know if you have the right data? And then you got to make sure you're following the data. So one of the things, again, the synergy of the 7 habits is how they all interplay with each other. And that is hypothesis, confirmed or busted. Hey, that was a previous one, but it's related to this. How do you know if you have the right data? It's just related to, do I have my hypothesis? Is my hypothesis right or wrong? And then given what I learned from this set of data, let's form some new hypotheses. One of the things I want to talk about too is plotting the data. Is this a tool or a method? I guess it is, but beware of statistics in a vacuum. I love statistics, don't get me wrong. I went and got a degree in statistics because I'm a geek. Love statistics, but I'm really hesitant to use statistics without in a vacuum, and certainly very hesitant to look at statistics without looking at the plot of the data. It's as important or more than the statistics themselves. I'm going to tell a couple of stories about this, about people who are driven by data, and I like to be data driven, and I'm going to bookend it with I spent about 25 years at General Motors, and I'm going to talk about my first week and my last week at GM before I retired, and it's a similar story. The first week, they were launching a vehicle. I know that one of my teammates had been struggling with a problem, and my boss finally asked me to talk to him and help him with it. And he's showing me all this data. We have, as you can see with the table here, we got some specifications, and we have a lot of variation, significantly more variation than they wanted. We have a huge proportion of percent of spec. Given this, they actually kicked off a new tool to build a new die, and they were going to kick off a major revision to the weld tool to get this variation down. Now, my issue was wait a second, can you plot this data? He goes, well, we're way past that. And I go, I don't care. Can you plot the data? And so they did, and it was really interesting. If you look, everybody just stopped and went, oh, because they had this mental model of a univariate, just normal distribution with a plus or minus 3. That's what their mental model was, given the statistics on the left. Look at the data on the right. You can see we have two populations. One population is pretty much centered around the mean and looks to be pretty in spec, and then we have another population that is shifted to the right. Oh, we didn't see that coming. Well, it turned out what happened was the system had not had Poka-yoke done or error proofing done, and during assembly, the operator would get install the part into the wrong state. So the one on the left, the hump on the left, is when it was properly installed. The one on the right was when it was installed incorrectly. My issue with the was no blame for the operator, because it was really a blind load, getting in the right position. There was no tactile feedback. There was no way for the operator to do this. So we made a small change to the part. It cost about 3 cents, but when I put in the change so that it was error-proofed, all of a sudden the hump on the right disappeared, and now we're in spec, and it costs about 3 cents. Oh, by the way, cancel weldment, cancel the welding tool, cancel the stamping tool. You guys were staring at numbers, not plotting data. So plotting data is a key one. Yes, that was my first week. Let's talk about my last week. It's similar but different. I was working on the General Motors full-size trucks. Biggest program in General Motors. It's where they make their money. My job right before I retired was to lead the problem-solving team for the full-size trucks. They called me when they had a problem, and the description of the problem was all about numbers. So, we have it's a true position of a hole. It can be no more than a true position of 2, so plus or minus 1 in any direction from where it should be. And they were looking at that percent out of spec was 97%. It's a disaster. Estimated high is 3.38. Oh my gosh, what a mess. What are we going to do with this? And again, I asked them, let's just plot it. We have 2 positions. It's the X and Z component, and just plot it. And if you look, the circle in red is where it should be, and you got very few parts in spec. But if I look at this, it's kind of interesting. In the Z direction, it's actually pretty much in spec. It's just off-center. The amount of variation is in spec, but it's off-center. And the variation in the X direction is much larger, and there we do have a problem. And then, but what else does it look like? It looks to me like the part rotated down and rearward. That's interesting. Why don't we just plot data? We've gotten into the habit with Excel and QDM and all these tools where people are so used to looking at numbers. I'm saying get away from numbers and start looking at plots. And almost always it'll give you clues. Once they realized that the part was rotated and had more variation in one direction than the other, we were able to quickly find a solution that got into spec.